So this lesson is over graphing two variable inequalities. So we're actually going to use the concepts that we practiced last week on graphing equations to come up with this, and then we'll talk about the inequality part afterwards. So the first thing that you're going to do with this is you're going to solve it for y. It makes making your table a whole bunch easier, so that's what we're always going to do. So to solve for y, it means you need y alone. So I'm going to get rid of my x because I do not want it with my y, just like I would get rid of a positive or a negative 2. This gives me 2y left over is less than, I've got a negative x minus 2. And then I need to get rid of the 2. How do you undo multiplication? With division. Now please remember, when you divide something by 2, you divide everything by 2. So this is going to be y is less than negative, and that's a 1/2 when it's written like that because that's a 1x. So negative 1/2 x minus 2. So what line do I graph? I'm going to graph y equals negative 1/2 x minus 2. And don't worry about this question. So the next part is going to be doing a table. And I'm just going to choose a few easy test points to figure out what my line should look like. So I'm going to plug in negative 1. So that's going to be negative 1/2 times negative 1 minus 2. So this gives me a positive 1 minus 2, which gives me a negative 1 for my chart. I'm then going to plug in 0. So negative 1/2 times 0 minus 2. That gives me 0. And 0 minus 2 is negative 2. My third and final point is going to be negative 1/2 times 1 minus 2. This is negative 1/2 minus 2, which gives me negative 2.5. So at this point, I'm going to plot all my points. So my first one is negative 1, negative 1. My second one is 0, negative 2. And my third point is 1, positive 1, negative 2.5. Okay. And I just noticed that my line is not straight, which probably means that I've done something wrong. With these, we're going to be doing all straight lines, so I'm thinking that my first value is not right. And as I look back at it, what I notice is that negative 1/2 times negative 1 is not negative 1, it's negative 1/2, which puts this at, positive 1/2, which puts this at negative 1.5. And so at negative 1, I'm at negative 1.5, and that straightens up my line a little bit. So as you notice, you should notice I'm going down 1/2 and over 1, down 1/2 and over 1. So I could actually finish out the rest of my line by going down 1/2 over a 1 to help me draw my line just a little bit straighter. Oops, messed up on that last one. So I'm going to do the same thing this other direction. And this is always a good practice, especially for when you get next year and you're drawing things, you're using drawing equations without tables. So the next part is figuring out whether it's a solid or a dashed line. So yesterday we looked at inequalities, where you dealt with stuff like x was greater than or equal to 2. When it was equal to, we did a solid or filled in circle, and when it was just a less than, we did an open circle. That's going to be very similar to what we're doing up here, except that we're going to do it with a solid or a dashed line. So because this is not equal to, we're going to say it's a dashed line. So what I mean by dashed is you're just going to make it look like it's not one solid line. And what that tells people is that you can go right up to this line, but your solution cannot be on that line. So from there, we need to figure out where to shade. Well, we're actually going to shade this one below the line, but how do you know that? Well, you're going to pick a test point. I always pick 0, 0. The only time I don't pick 0, 0 is when the line goes through 0, 0. And the reason I pick 0, 0 is because it's very easy to plug in. So just like yesterday, I'm going to plug into my original, which is x plus 2y is less than negative 2. So that 0 plus 2 times 0 is less than negative 2, which is 0 plus 0 is less than negative 2. That gives me 0 is less than negative 2. Is this a true statement? 0 less than negative 2? No. So since it's false, that means wherever 0, 0 is, I can't shade there because it's false. If it was true, I would shade there. So that means I'm shading underneath my line. And that's based on my test point. Okay? So below, how do I know? Because of my test point. Okay, let's try another one because I know these are a little bit complicated. We're going to skip this one because it's not in your notes. Okay, so this next equation is actually already solved for y for us, which is very handy. So I'm just going to make my xy chart. I usually do -1, 0, and +1. You do need 3 points to be able to graph a line, so that's what we're going to be looking at. So this is going to be y is greater than or equal to 3 times -1 minus 3. Really, you're not going to have to worry about what this is at this point. It's just the answer that you get from this will be what you put in for your y. So this is -3 minus 3, which gives me -6. Now I'm going to do 3 times 0 minus 3. 3 times 0 is 0, minus 3 is -3. 3 times 1 is 3, minus 3 is 0. So I've got my 3 points. I'm going to do -1, -6, 0, -3, and 1, 0. Hopefully you notice that every time you go up 3, you go over 1. So with that, you can fill in the rest of your chart by going up 3 over 1, up 3 over 1, up 3 over 1. And then you can go the reverse direction, down 3 over the other direction 1. And that'll just help you get a cleaner line. That has an equal sign underneath it, so it's actually going to be solid. That means we can go right up to this line. We don't have to right up to and on top of it. So my line does not go through 0, 0, which means I can use 0, 0 as my test point. Remember, your test point should always be plugged into your original equation in case you've made a simplifying error. 0, it should be greater than or equal to 0 minus 3. So is 0 greater than or equal to -3? True. That means wherever 0, 0 is, that's where I shade. Okay? So on this one, we're actually shaded above the line. Our next example is not solved for y, so I do need to do that. This is the part I need to get rid of. So to get rid of a -4x, I add a 4x. That gives me y less than equal to 4x plus 8. Y is all by itself now, so I'm ready to make my t-chart. So -1, 0, 1. So this is going to be 4 times -1 plus 8. That's -4 plus 8. So +4, my answer. 4 times 0 plus 8. This is 0 plus 8. So 8 is my answer. 4 times 1 plus 8. That's 4 plus 8, which is 12. So I've got -1, +4, 0, +8, and 1 is going to be off my graph. So I've got to look at the rate of change that I have here. 1, 2, 3, 4, and going over 1. So every time I go up 4, I'm going over 1, which means going the other direction, I could go down 4 and over the other direction 1. See how it's continuing to make a straight line? All of these that we deal with will be straight lines. That right there tells me that it's solid. just like yesterday where we had a closed circle for that. And then I need to pick a test point to figure out where I should shade. So I'm plugging into my original and testing it out. This is 0 minus 0, which is 0. Is 0 less than or equal to 8? Yes. Which means wherever 0, 0 is, that's where I shade. Okay? So let's take a look at the next one. This one's already solved for y for us, so we're just going to do a t-chart. Again, -1, 0, 1. So this is going to be -1 plus 1, gives me 0. This is going to be 0 plus 1, 1. 1 plus 1, 2. So I've got -1, 0, 0, 1, and 1, 2. Notice it's going up 1 over 1, up 1 over 1, so I can continue to do that all the way across. And again, that just helps you make sure that your values are coming out right and that you're drawing a straight line. This tells us that our line should be dashed. And I usually do that just by connecting every other one. It's easier than erasing. And so this is my line. Here's 0, 0. So I'm going to use that as my test point since my line does not fall on it. And that's going to be 0 is greater than 0 plus 1. Less than. 0 is less than 1. Is that true? Yes, it is. So because it's true, I'm shading where I see that 0. So that would be under here. Now, at this point, you should kind of start seeing a pattern. Notice that we've solved for y, and it says y values are less than x plus 1. Notice that we shaded underneath, if you look at the top of the line, we shaded underneath the line. That's because everything is less than. When this one was solved for y, it was less than. So here's the top of the line, we shaded underneath it. This one was greater than, here's the top of the line, we shaded above it. That's why we always solve for y when we look at these problems. So let's check a few more. This one is not solved for y, so I have to do that first. I want my y to be by itself, so I'm going to get rid of the 9x. That gives me 3y is greater than or equal to -9x plus 6. I also have to get rid of multiply 3, and I do that by dividing by 3. Just remember, you have to divide everything by 3. So y is going to be greater than, that means I should be shading above the line. -9 divided by 3 is -3x, and 6 divided by 3 is 2. So now I have to make my t-chart. -1, 0, 1. So this is going to be -3 times -1, which is +3 plus 2, so 5. -3 times 0 plus 2. 0 plus 2 is 2. -3 times 1 is -3. So -3 plus 2 is going to be -1. So I have -1, +5, 0, 2, 1, -1. As you notice, I'm going down 3 over 1, down 3 over 1. So I'm going to continue that rate of change, that same pattern, and do it in the other direction to complete my graph. Because this has an equal to sign, it's going to be solid. And I'm going to shade, here's the end of my line, I'm going to shade above it. However, to verify that, I still do want you doing a test point. In this case, our test point still can be 0, 0. So I'm going to plug back into the original, which was 9x plus 3y. And that had to be greater than or equal to 6. So 0 plus 0 is greater than 6. That's 0 is greater than 6. this is a false statement, which means where my 0 is, I cannot shade there. So that's why I'm going to be shading on top of the line. All right, so 2 more examples. The next one is already, again, in y equals x form. So y is by itself. So we've got xy, and again, I'm going to do -1, 0, and 1. So if I plug in y and -1, then that's just going to tell me that y is -1. Sorry, let me put an equals there. If I put in y and 0, then y is going to equal 0. If I put y and 1, then y is going to equal 1. Basically, this is just saying whatever you plug in for x is going to come out the same for y. So we've got -1, -1, 0, 0, and 1, 1. So this is going up 1 over 1 every time. So I'm just going to continue that pattern all the way across. From there, I did notice that it is an equal to, so it should be a solid line. And picking 0, 0 this time is not going to help me because that's actually on my line. So when I do my test point, I just need to choose something else. So I'm going to choose -1, -1 right here. If -1, -1 is true, that's where I shade. If it's false, then I don't shade there. I shade the other side. So when I plug in -1 for y and -1 for x, is -1 less than or equal to -1? Well, yes it is, which means I can shade down here. Our last problem is also in y equals x form for us, where y is already alone. So I'm going to plug in -1, 0, and 1. So 1/2 times -1 plus 3. That's going to give me -1/2 plus 3, which is 2.5. 1/2 times 0 plus 3. That's going to give me 0 and 3. 1/2 times +1 plus 3. That's 1/2 plus 3 gives me 3.5. So I'm going to go to -1 and 2.5, 0 and 3, 1 and 3.5. Now hopefully you noticed I'm going up 1/2 and over 1. So I'm going to continue that pattern all the way up so I can get a nice clean line. And the other reason we do this is because it helps us with estimating purposes later on. Now, it's not equal to, so I'm just going to draw in dashes instead of a solid line. That means it cannot be on the line. It can be above or below, but not on. Now, 0, 0 is not on the line this time, so I can use that as my test point. So y is going to be 0, and I need that greater than 1/2 times 0 plus 3. So 0 is greater than 0 plus 3. Well, that 0 is greater than 3, which is a false statement. So that means I cannot shade where my 0, 0 is. I have to shade on the other side of the line, which is above the line. So that should kind of make sense because it's a greater than. All right, so we've got a few more sample problems. Some of them are 2-step and some of them are 2 variable and some of them are 1 variable. So on the 2 variable ones, you are coming up with a table so that you can graph the line, and then you're choosing a test point so you can figure out whether to shade above or below. The 1 variable ones are like the ones that we did the other day, where you put them on a number line. Okay. So make sure you complete that worksheet, that assignment, and we'll go over it tomorrow.